Hello everyone. My name is Jean-Philippe, or JP. I work at SUSE. I'm a product manager dedicated on the virtual cluster and multi-tenancy. And I'm here today with Arnab.
Hi everyone. My name is Arnab Chatterjee. I am part of Nomura, which is one of the leading investment banks in Japan. I head the container and cloud platform in my organization. And today I am joined with JP. That's a short form of your name. Just made it up.
Yeah.
So yeah, we'll get going. It's going to be a very interesting talk, and we'll try to keep a bit of humor alive as well. Off we go.
Cool. So today we are going to talk about what are the main challenges to approach multi-tenancies, how we can address them in SUSE Rancher Prime. We have a demo for you, so you have to stay now. And I'm going to talk about, surely you've mentioned that in Pete's talk, keynote, there is an early adopter program, so I want to talk a bit about that later.
Thank you. All right, let's start with a dream. By the way, I am from Mumbai, and like most of the financial capitals around the world, like New York and London, this indeed is a dream for me. Yeah, picture perfect. Look at this. Lovely house, private area, no noisy neighbor, pleasant people. Everything is all yours. And it's like, it's an ideal state. Life is a carnival. Of course, the stairs is yours, the parking is yours, the rooms are yours, and of course, the bill and the credit card is still yours. And that is where the cookie crumbles, at the affordability of such houses. Now, the analogy, when I compared this to the cloud-native Kubernetes world, is clearly a single-tenant cluster, where you have a dedicated cluster for an application team, where they have their own storage, networking, resources, memory. They hardly bother about the cost. They stay well, they stay happy, till the cost grows. Now, this is very far away from reality, be it myself, or be it most of these setups that we have in industry. What reality looks like is something like this. Yeah. Take a look at it. You know, it's a congested multi-story apartment where you have a gamut of people staying together. Looking at the size of apartment, I'm pretty sure we don't even have ample parking to park all the cars. Lifts, I hope they are high speed. And comparing it with Kubernetes world, this is how actually a multi-tenant cluster is set up. You have a single cluster being distributed among multiple people, like X applications, and they all stay together. And they stay happily. Oh, do they stay happily? Not in reality. You know, with sharing and lowering of cost, there is always a price that you pay. And that is what we're going to talk about, followed by the remediation. I just mentioned about the problems that we see in a multi-tenant setup. The great parking debacle. Yeah. The apartments are really high, and it might have 100, 200 flats. There aren't many parking as a car. Now, each household now, anticipates 2 or 3 vehicles. But do we have sufficient amount of parking space to accommodate it? The answer is no. So what happens is, if you're lucky to come home early, you'll get a slot. If not, you'll do rounds and rounds like a vulture waiting for a prey. And if you don't get lucky, then apparently you have to park your car somewhere under a tree, and tree is like full of birds and pigeons, and they really make the car dirty. And believe me, it's very tough to clean a car. Similarly, in a Kubernetes world, you are always, these pods and applications and deployments are fighting for resources. And an analogy to parking is they all try to spin up at the same time. There is scarcity of resources, CPU, memory, and what your pods see is they keep staying on a waiting state. Kubernetes answer to, there is no parking available for you. Keep waiting, a pain. The second problem is the elevator ordeal. Wow, this is an interesting one. Specifically, if you're staying on 50-story building, just imagine it's a peak hour where you're going to the school or the college with the kids, or you're coming back from the office, and you have got ample amount of people, and just limited parking, and just limited lifts. So what happens then? Not everybody can get into a lift, and for any reason, if the person staying on the top floor or ground floor goes to the lift stops at every floor, every single floor. It's like it's doing a guided tour for you. Not really helping your cause because you're running against time. In Kubernetes, it's like you have multiple cron jobs scheduled, and we have too many cron jobs scheduled together at the right time. There are high chances that there will be starvation, and they'll not really trigger at the time it is supposed to get triggered. Because again, limited resources, more people. The noise pollution stuff, in your own house, I just spoke about you don't have a noisy neighbor, but with respect to an apartment, you have got a neighbor on the left, a neighbor on the right, and you've got sometimes the nature of the neighbors vary. You have, like I had a neighbor who was a musician, so 10 a.m., 12 a.m., 2 a.m., he would just start playing the karaoke loud and start dancing. And I didn't have soundproof doors at night, so it was a bit of a chaos. And then I had a neighbor who was a pilot who would come home and start using his vacuum cleaner, which would have a 500 megawatt motor, and it would make noise like a hacksaw running. You couldn't sleep. In case of Kubernetes, a similar situation can happen, where you have multiple pods trying to gobble up depending resources. And the kind ones who were running fine get impacted. It's like the Hunger Games analogy. And finally, every building has a common trash chute where garbages are supposed to get dumped. But imagine a tenant who would treat old furniture as garbage. He would dump all his furniture in the chute, and that would create chaos and pause the system. Very similar to in Kubernetes, if you have an application that's writing logs endless, going into an infinite loop, or a memory leak for a pod. Very relatable. So, is there a solution to this? Or should we go back to staying on a single tenant cluster and pay more? Or is there a way that we can go back to a single tenant cluster and not pay more? A bit of facts this time. Gartner research, last couple of years, we have seen the explosion of Kubernetes. Most of the applications and industry are moving and getting cloud native, which means they are growing more. The cost uptick is pretty much evident. So when Kubernetes was initially onboarded, like in 2018-19, that point of time, the whole idea of the community was to get it up and running, get it working. And once that was done, the focus was around how to monitor the cost. The overspending of the cloud budget primarily was found out as over-provisioned Kubernetes cluster. As we saw in few of the sessions earlier in the day, you would reserve a lot and not use it. But then, did we have an option to do it? Because I just mentioned so many problems related to a shared tenant model. So the answer was inherently there in Kubernetes. But before that, we would like to see how the problem exploded. So there are two problems. The cost, when you talk about cost, there is the financial element, and there is also the people element, which is around management of these infrastructure resources. So you have different clusters for application team, which keeps them happy, isolated, not very happy when the bill comes. But for the platform team and the SRE team, it's a massive overhead to manage so many clusters, having visibility of each cluster, problem areas, observability, pain point, rushing from here to there, trying to find a product which is a single pane of glass across the clusters. It becomes unmanageable. And the cost extrapolates as well. And the solution was there with Kubernetes, namespace-based multi-tenancy. And it's not a new concept. It's something that was always there with Kubernetes. But there are certain elements and many questions that came up from the platform team, from the SRE, from the cloud operations, that it's there inherently present, but how to get it done in a right way. Namespaces, yes, you can assign a separate namespace for each application team. They would have their own footprint around it, and they expect to be bounded and controlled without any interaction or without any chaos Network policies, yes, when you have isolation namespaces, your network policy, which was bounded only at the cluster level, do percolate at the namespace level. So there are changes at the network policy to make sure that there is no crossover when you have tenants across each other unless they really want to do that. Resource quota is really important for fair usage. We spoke about one bad pod can come and gobble up everything. How do you stop that with a namespace-based multi-tenancy? Is it actually even possible? Because ultimately your pods can spin up and turn over to any particular machine on the infrastructure. How to manage that? What is the fundamental control behind it? These are the questions that popped up immediately across the different teams. RBACs, cluster level RBACs, namespace level RBACs, how do they get married to each other? Is there something out of the box, or there is more work towards it? And of course, you have these people who are used to staying in an air-gapped, very isolated environment on hard multi-tenancy. Can it be achieved using namespace-based multi-tenancy? So these are the questions that keep on coming to people. And what happened was, so that's only the tip of the iceberg, but yes, namespace-based multi-tenancy, it can be done. Workload isolation, fair usage policy, tenant autonomy, 3 pillars of true multi-tenancy needed to be addressed. But in spite of doing that, showing it as bells and whistles, there were a lot of wrinkles that evolved and came up. I'll just touch base upon a few examples of doing things correctly, and if you don't do things correctly, what are the risks associated to it? Good analogy, isn't it? A single cluster, a single team, their own policies, their own resources, their own constraints, their own deployments, their own workloads. Well, it was a different cluster for the application team and the platform team that was supporting it. The SRE team, they were aware of what's going there in the cluster. Be it onboarding of the application, or be it debugging it, or analyzing what's going wrong. It had a limited scope. Now what happened here was, with the multi-tenant cluster, you suddenly have 200 applications on the cluster. Onboarding them via GitOps, your YAML blows out of the proportion. What's happening is, you suddenly become a curator of a YAML dictionary. The YAML is supposed to be simple. It made life complicated for most of the people. Observability around YAML, what's broken things is it required deep insight. It needed attention, it needed implementation over the cluster level to the namespace level. So the idea of observability and standardization became of paramount importance. So what happened was, it added more pain and more work for the platform team to enhance the layers on top of it. We spoke about this, isn't it? How do you isolate workloads? It's a shared cluster, right? Everything, any pod can run on any specific machine. Okay, it's possible. You look at, in the world of virtualization, you have affinity and infinity. You basically want to make sure that certain workloads run on specific machine, dedicated nodes to it, then how it makes things efficient. Then if you are dedicated machines, we are increasing the number of nodes. And if you're not using it, it's a bigger bill. How to make sure that you don't have root consumers, and even if you have root consumers, how to split boundaries across it. Now, a single mistake can lead to a lot of noise in such case. Oh yes, networking in Kubernetes is anyways complicated, even in a single tenant cluster. That's a fundamental core of Kubernetes, be it your ingress resources, be it load balancers, be it the policies, be it the CNI settings, be it things like egress gateway, resiliency. It's not a straightforward thing to do, even in a single tenant cluster. And come the layer of multi-tenancy, it becomes a spaghetti bowl of network rules. So yes, it is another layer of complication. So as people keep on repeating, is juice worth the squeeze? In spite of doing all these things, are we getting what we require to get? And yes, and everybody will be able to relate to it. The final problem is the upgrades. It was a saying in the old distributed world that a single big mesh is a single big mess. And this is the reason why. Your tenants sitting on a Kubernetes cluster, you have 200 applications. Back in those days, every application will take their own sweet time. But now, everybody has to go live and get upgraded at the same time. And what happens then? Your vendors talk about giving you a LTS support for a year, but sometimes upgrading and making sure every application team sign off takes 4 months. How does that help you? Do we have solution to this problem? And bear me, I mean, people would be aware if things go wrong here, we talk about rollback or a fix forward. And either ways, things can go wrong. Having a blue-green environment is a resource waste. So what is the solution to it? So easier said than done. What we are doing is we are not really isolating people. We are not giving them the actual tenant autonomy. We are not providing the solution of true isolation. And the most important part is we are not democratizing the work. I, as a platform engineer, as a platform owner, I want to do a shift left rather than doing all the work for my tenants, for my application team. I want them to have more autonomy. I want them to drive their own deployments, their own operators. Anything that needs a cluster level control can't be done even with this model. If I have got a set of people who wants to deploy an operator, they can't do it because they need cluster level controls. I would have to do it for him. XDDC will work for them. Unless it's a cluster-wide central application, it doesn't make sense for me. Paralysis again. I'm talking about problems a lot. I'm pretty sure you guys are inquisitive to understand how this can be sorted. With that, I would want to invite John Paul. Over to you.
Thank you. Right, so we have now a great set of challenges and problems to resolve. So how we can tame that multi-tenant monster currently in Rancher? Well, we have the soft multi-tenancy, which is Rancher project. Everyone use that. It's really great to aggregate namespace, control user access, do the quota management, and it works really well. And we also have the hard multi-tenancy, which is SUS virtualization powered by Harvester that allows users to create dedicated VMs, spin up their cluster, right? Well, then problem solved. And thank you for your attention, right? If you see the demo Palooza this morning, actually, you may have noticed that we are introducing something else, something in the middle. I'm going to show you that a bit after. But yeah, right now, the problem is that soft multi-tenancy doesn't provide a solution to our NAB's problem, which is noisy neighborhood, right? Especially if you have multiple teams that want to run operators. You want them to be autonomous, but the problem with operators is that then you are touching the cluster level resources. There's still a risk for users to compete for resource, especially in the soft multi-tenant environment. Network policy, that one is a nightmare. You still have to manage everything, right? And the one downside with the hard multi-tenancy is that it adds an additional cost on your infrastructure. So that's why we worked actively on a solution that will provide you an intermediate level of multi-tenancy, which is called SUS Rancher Prime Virtual Cluster, which is powered by our Kubernetes in Kubernetes engine Key3Key. Everything is available. It's open source. I'll share the link after. But the idea of that solution is to provide a cluster resource isolation, right? So think about the resources such as custom resource, operators, cluster roles, all of that are now kept locally, and they don't interfere with the host cluster or other virtual cluster. And we want to have the best UX as possible. So we want to make the multi-tenancy easy for host admin, tenant admin, and cluster users. Right, so I'm going to deep dive a bit later on that. And of course, we want to support GPUs and also other nodes capabilities. Okay, so now if we take a look at the problems that Anna mentioned, we can now see how we can address them using that new piece of technology. The first problem was the great parking debacle, right? The problem for a team to find a spot, right? Hard multi-tenancy does solve that challenge instantly because each tenant, each user has their own tenant, own cluster, right? In soft multi-tenancy, it's managed using resource quota at the namespace level. And actually, Key3Key will leverage the same approach that works well with project, and it will work in addition of what the project can do. And you should be able to set the quota per virtual cluster or per group of virtual cluster as well. And one of the greatest features of K3K is actually its tiny footprint. It's very small. And because it's running, it's using Kubernetes capabilities, you are only consuming what you need to consume in terms of CPU and RAM. You don't need to over-provision. You don't need to assign a bunch of resources. It's only consume the resource it needs to consume. The other problem is the noise pollution and lack of self-proofing. That's one that K3K will shine actually today, and solve that problem. So as we are going to see in the demo, a cluster user cannot interfere with the host or another virtual cluster. That's really the key piece here. So resources such as custom resource, namespaces, any cluster level resource are really kept locally and isolated from the rest. The other true problem will be addressed in the future, if possible. K3K will not solve everything. It's not the perfect solution. It's one solution. All right, and now, so you also mentioned 4 challenges. Just pick the first 3. Second one is a bit more detailed because it's very interesting. So the great wall of YAML, how we can avoid managing that much YAML that you just described, right? Well, Rancher actually managed that pretty well. Like, Rancher is a good abstraction of the amount of YAML you need to manipulate because you have the Rancher UI, you have APIs, you have Terraform, and you have some umbrella resources that will help you address that. And K3K will be fully integrated in Rancher, so actually we'll leverage all of that. About the Hunger Games, again, so one of the key features from K3K is for the user to be able to maximize the infrastructure investment by running multiple K3S clusters on the same host. And last but not the least, K3K in an additional resource that we are introducing, it's called cluster set. That will provide you the capability to have out-of-the-box, without configuring anything, network policies, resource quota, and the capacity to group your cluster. Right. And it will be, so that's, I'll talk about the roadmap after, but yeah, the idea at the end is that everything will be integrated with other Rancher Prime products. So Neo Vector, we saw this morning in the demo, Palooza demo, it's already in SUSE observability. So we're going pretty fast on that. And the upgrade ordeal, that's a really interesting one. So currently, it's completely work in progress. We are actively working on it, and we want the best UX as possible for that. Upgrading a virtual cluster should be as easy as changing the version in your cluster resource, and that's it. At least we'll try to do that. There will be some rules bound to the support matrix of Rancher and so on. But really here, the 2 main objectives are first to empower the virtual cluster user to be autonomous, and they can do their upgrade when they are ready to make their upgrade. And for the platform engineer, they don't need to wait for every user to be ready to actually upgrade the host cluster. All right. Last couple of slides before the demo, so bear with me. So remember that picture? That's a huge challenge that you just described, right? Because you need to manage everything, right? So the idea is to go from this to this and actually simplify the UX. So we're really investing on the user experience for that part. And the idea is to use some resources cluster set that will help us configure out of the box the network policy, the quota, and stuff like that. And then we used all the Rancher integration to simplify the airbag and actually leverage what Rancher does really well for managing the users and the airbags. And we want to introduce some new persona for Rancher, so new roles dedicated for tenants, especially a tenant admin. So on this setup, there is rancher manager, an host cluster deployed on AWS. And so in order to be able to use Key3Key in Rancher, there is a beautiful UI extension, not fully yet available, it will be soon. And the idea is that by enabling that, you have access now to a new kind of cluster that we can deploy. Just as any regular cluster, you choose a name. Then I'll just pause here a bit. Then you need to choose which host cluster you're going to deploy your virtual cluster. So that's the part that differs from the regular provider, RKE2, that you can find. And we also added a very convenient way to deploy the Key3Key technology in the host cluster. So you don't even need to deploy the Helm chart or anything. It's there in the UI. Now you can choose a mod. I will not get too much into the details for that. It's fully documented on our GitHub repository. But in a nutshell, choose virtual mode if you need a strong isolation, and the shared mode if you need low overhead and you want to use GPU. Right? So I'm gonna, on the demo, deploy a cluster in both modes. You actually be able to show you what the main differences are. But yeah, don't want to spend much time here. And then you could do networking, member role, label annotation, just as any cluster. All right, and we're going to see behind the scene what's happening, right? We don't want just to wait. So let's see what's happening on the host cluster point of view. So some stuff are popping. We have the server, the virtual kubelet, and a jump to one port. All right. I'm going to speed up a bit here. It takes around, in this setup, like 3 minutes for 2 minutes and 30 seconds for the cluster to be running, 1 more minute for the cluster to be imported in Rancher. I think Demo Palooza this morning, they managed to have that in 1 minute. That was pretty impressive. And what you can see here, that's the specificities of the shared mode. Everything is running on the host. So you are sharing the host capabilities, and you are creating actually your pods on the host. But you have access to a dedicated, that's what I'm going to show you, a dedicated Kube API endpoint. And from the user point of view, he has his own cluster. And then because it's fully integrated in Rancher, imported in Rancher, then you can download the kube config and manage your user. It's a regular Kubernetes cluster imported in Rancher. And now you can access the cluster, see that you have nodes, not the same version as the host cluster, so you are in the right place. Now, I'll put my developer hat. I have a web app. I want to deploy it. I have access to my own tenant. The first thing I want to do, yeah, it will come just a bit after. Okay, the first thing I want to do is to deploy my ingress controller, because it's a web app. I want to expose it. And what we are going to see is that some resources are going to pop on the host cluster directly. And now I want to deploy my apps. So a brief overview, it's a really simple apps, a deployment, a volume, a service, and ingress. That's it. Simple app. Just need to wait, yeah, cool. All right, and the app is created. So now I can fetch on which services my ingress controller is running, and I'll do everything from the point of view of the tenant user, the virtual cluster user. So he has access to every information that he needs to access. I can retrieve on which port my load balancer is deployed, and then access my app. I don't need to access any of the data from the host cluster. Everything is from the virtual cluster. And now the next part is actually to showcase the CRD isolation, because one of the main use cases for that is running multiple operators and avoiding teams to step upon each other's feet. So in my case, I'm going to choose KubeWarden. This is a product. It's a good one. So on the host cluster, I don't have anything related to KubeWarden in terms of CRD. I'm just going to watch what's happening, and then I'm going to deploy on my virtual cluster the CRD for KubeWarden, and then I'm going to deploy the application as well. And that's also a good introduction to how you can secure both of your host cluster, but also the virtual cluster. So you can deploy KubeWarden, for instance, inside the virtual cluster, but also on the host, and to provide guardrails for every of your user. Basically, voilà, the application is deployed, and I see that on my host cluster, nothing appears. So the CRD are kept completely locally on the virtual cluster. And now I want to deploy a second virtual cluster, but I'm going to choose the share mode, so we can see a bit about the difference. So yeah, on the virtual cluster, we can see that we now have some KubeWarden CRD. We have the KubeWarden apps. Okay, so now we can see a bit about the difference between the two modes. So I'm just going to deploy a second virtual cluster. I'm going to choose virtual mode this time. I'm not prompted to install Key3Key because I've already done that in step 1. So that solution also detects if it's installed or not. I'm going to just choose a node. And because I can change the network as well, we can do some configuration. It's a regular cluster. So for the shared mode, it's written here, but it's very important that the service-sider is the same in the virtual cluster than your host cluster because you are syncing your services. But fully explained in the documentation. And out of the box, we are of course compatible with RK2, Key3S, so we share directly out of the box the same cider. The cluster is deploying, so again, a bit of fast forward. Otherwise, it will be weird for us to wait 5 minutes in silence. But this time, what you can start noticing from the previous deployment, you don't see anything appearing here. That's because you have your dedicated worker nodes as pods, and you have agent. So you have a stronger isolation. The host cluster is not then aware of what's running inside of that. So that's a different mode. It's similar to Key3D. It's Key3D inside Kubernetes directly. And then once it's imported, as the same as the other modes, I can just export the kubeconfig and then connect to my cluster. And now the idea is to deploy KubeWarden again on that second cluster and see that it won't interfere with the host. And I can also choose a completely different version of KubeWarden. So I can see here that now I have, compared to the precedent deployment, I have my agent, I have my server. It's really like a full Key3S or Key2 kind of cluster. And as you can expect, nothing is replicated on the host. So everything is also kept completely locally on the virtual cluster. So I'm just going to pause here and go back to the slide. So, wow, can I try it? Yeah, of course you can. It's on Key3Key. It's in the Rancher repository, completely open source. You can start playing with that. We love feedbacks, so if you run into any issues, you have absolute brilliant ideas, just share that in the GitHub, and we'll make sure that we tackle that. And what's next? So I wanted to touch base a bit on that. So we are in an early adopter access phase, which is about providing Key3Key core to our prime customer. So if you're a prime customer and you're interested, please reach out, and we can arrange how you can get started on that, on the program. The second phase of the early adopter access will be focused on the integration of Key3Key in Rancher with this new persona and the full integration with the UI extension and everything. And in the timeline, we are planning to start that in June of this year. And then the GEA will follow later this year. All right, thank you. Any questions?
Thank you, everyone.